Thank you, Martin, for the introduction. So I'm Alexandre Kremer. I'm the co-founder of Radical Dot. And what we do is we are building the next generation of chemical recycling technology. One which allows you to unlock carbon from complex plastic waste. I'm in KFR today, so I don't need to explain you the fact that plastic is a very complex material. We use just one word to describe actually thousands of different polymers. And that's what makes it complex to recycle and costly to recycle as well. As a matter of fact, over 90% of plastic waste is not being recycled today. And but what I'm extremely excited to see in KFR today is so many companies which are actually looking for circular solution and a sustainable solution for their plastic waste. On the other hand, and rightly so, those companies are also looking for cost-competitive solutions, and that's what has made difficult for a lot of recycling process to date. And this is exactly what Radical Dot is aimed at, is building the the second generation of chemical recycling technology, which is both cost competitive and sustainable at the same time. So how do we do that? The chemical recycling technology that we are building is fundamentally different from the one that you have heard in your traditional chemical company. It's not pyrolysis, it's not gasification, it's not PET depolymerization, it's not solvent-based recycling. We call it liquid oxidation. It's a chemistry which is very similar to what nature does. That means that we take the oxygen from the air and we use it to break down a wide variety of plastic chain. That leads to the formation of carboxylic acids. But instead of doing it over thousands of years, what you see in nature, we do it in less than a few hours. If you don't know what carboxylic acid actually means, this means acetic acid, succinic acid, adipic acid. Acetic acid, you know it because it's in your vinegar, but it's also a massive chemical for the adhesive industry. PVAC, EVA, EVOH that you find everywhere around you in your paper packaging, in your furniture, in your shoes. Succinic acid is the precursor of a wide variety of monomers which are being used especially in the biodegradable industry. And finally, adipic acid is very well known for its application in the nylon industry as a precursor for PA6. Those carboxylic acid represent today a 23 billion market value, whereas there is actually very little to no application to make it recycled content. But what I find extremely interesting about carboxylic acid is not only its market itself, it is potential to become a platform for the chemical industry. Indeed, most of those carboxylic acid can be turned into alcohol and olefin and provide a much larger opportunity for the industry to defossilize a quite large number of molecules which today we cannot access. Going back to our technology, there is 5 things that are setting us apart. The first thing is the fact that we are feedstock agnostic. As I mentioned already, we can deal with the complexity of mixed and contaminated plastic waste with a technology which is quite robust. Second thing is the fact that we are cost competitive. We can produce chemical in par with fossil technologies. Our technology is intrinsically scalable, meaning that it relies on processes which have been, and chemistry which have been scaled already. They've just never been applied to chemical recycling before. Our technology is also energy efficient. We are producing quite a bit of energy in our process, which we can leverage to actually power the rest of the process, meaning that we can decouple our techno-economics from energy prices, which is one of the issues that many recyclers are facing today. And finally, we are producing recycled content chemicals, not only recycled content, but obviously lower carbon emission chemical. And today, there is no alternative to produce recycled content acetic acid, recycled content succinic acid, and recycled content adipic acid. a little bit about our story. We started 2 years ago. We're based in the Technical University of Munich. We're working across the value chain with waste management players in both France and Germany. And we are moving to a pilot right now, which is enable us to operate at the kilogram per hour scale. The goal in the next 2 years, and that's why I'm in K-Fair today, it's to build our first demonstration plant, which would be able to operate between 100 to 200 kilograms of plastic per day to be able to demonstrate the technology at a chemical park in Bavaria. And we are looking for partners which are willing to test our product down the line as well. So if you're one of them, please don't hesitate to come to me afterwards. A short thing about our team, we have a team of 10 people, chemists, chemical engineers, polymer chemists as well, and are supported by a veteran from the industry from BASF, Borealis, and BP as well. With this, thank you very much for listening to me, and looking forward to unlocking carbon from your complex plastic waste together. Thank you.
Thank you very much, Alex.